We're going to unpack this mind-bending concept known as the Solow Residual and explore a really provocative question. Is artificial intelligence the hidden force that's actually driving our global economic growth? Look, it all starts with one very simple, undeniable fact. The global economy just keeps getting bigger. If you zoom out and look at the macroeconomic data over the long haul, global GDP is absolutely growing. We're talking more wealth being generated all over the world, way more goods and services being pumped out across every sector, and just an overall economic output that's on this relentless upward trajectory. Year after year, we are simply producing more stuff than we ever have before. Now, what's really interesting about this slide is the massive contradictions staring right back at us. The usual suspects that traditionally drive all this growth, they're actually lagging way behind. Capital, for instance, isn't really growing that fast relative to our overall output. And labor? Get this. In a lot of developed countries, the labor force is almost completely flat. Our populations are aging, birth rates are dropping, and frankly, we just aren't adding that many new workers to the global talent pool anymore.
Which brings us to the massive mystery at the heart of today's explainer. Think about it. If we aren't suddenly building an unprecedented number of new factories, massive server farms, or physical machines, and we definitely aren't adding a massive wave of new human workers to our assembly lines and office buildings, then what on earth is actually driving this continuous, relentless economic growth? Well, the answer involves that fascinating concept I mentioned earlier, the Solow Residual. And as we'll see, it is deeply, inextricably linked to modern artificial intelligence.
Okay, a quick refresher. Historically, economists like to boil production down to two main inputs. First, you've got capital. This is the tangible stuff, the physical machines, the heavy infrastructure, the factories, the hardware. Second, you have labor, the actual human workers, the hours they're clocking in, their blood, sweat, and tears. Naturally, for a long time, the assumption was simple. If our output goes up, it absolutely must be because we poured in more capital or we threw more labor at the problem to get that result. Simple, right? But here is where it gets wild. When economists actually crunched the hard data, they found a massive, surprising twist. A huge chunk of our economic growth literally cannot be explained by just adding more capital or more labor. The math simply does not add up. There is this invisible factor at play, a massive, unexplained leftover that is steadily pushing our global GDP higher and higher without us needing more physical machines or more human bodies. Section 1. The math behind the mystery. Let's break down exactly how this works. Okay, let's dive into this. To really grasp what's happening, we just need to look at a basic production function. Economists express this with a pretty elegant little formula. Your output, which we call Y, equals a function of your capital and your labor. That's the F of KL part. But here is the secret sauce. We multiply that entire function by A. And A stands for technology, or more accurately, our overall productivity. So the whole formula is Y equals A times the function of capital and labor. Now, here is the critical step, where the mystery really reveals itself. If we want to figure out how fast technology or productivity is actually growing, we just do a little algebra and rearrange that equation. We take our total output growth, and we subtract the contribution of our capital, and then we subtract the contribution of our labor. Whatever's left over, that lingering gap after we account for those physical inputs, is our unexplained leftover. And that specific leftover is famously known as the Solow Residual. Let's anchor this math with a concrete real-world example, just so we can see exactly how this residual is calculated in practice. To do this, we need to establish the income shares for our inputs. So for the sake of this specific calculation, let's suppose that capital's share in income is 40%. That means labor's share makes up the remaining piece of the pie at 60%. All right, let's play this out. Say our total output grows by a really healthy 5% over a given year. Meanwhile, our capital grows by 6% and our labor force grows by 2%. We multiply capital's 6% growth by its 40% share, which gives us a 2.4% contribution. Then we take labor's 2% growth, multiply it by its 60% share, and that gives us a 1.2% contribution. When we add those two together, 2.4 plus 1.2, the total economic growth we can explicitly explain using our standard inputs is just 3.6%. But remember, our total output actually grew by 5%, right? So 5% minus the 3.6% we just explained leaves us with exactly 1.4%. That 1.4% right there, that is the Solow Residual. It is the exact mathematical representation of the economic growth that we literally cannot attribute to just buying more machines or hiring more people. It's the magical gap between the effort we put in and the extra value we somehow manage to get out. So what the heck actually makes up this leftover 1.4%? Well, it's way more than just technology in the narrow sense of, microchips and software updates. It includes better organizational structures. Actually, scratch that. It's more like a completely upgraded way of running a business. It accounts for improved management practices, human capital improvements like having a more educated workforce, pure scientific innovation, massive efficiency gains, and yeah, sure, sometimes even simple measurement errors. Basically, it acts as a giant umbrella for everything that makes a society work smarter rather than harder. In modern economics, we've actually given this residual a specific name. We call it total factor productivity, or TFP. Total factor productivity is the absolutely crucial conceptual bridge that takes us from this historical macroeconomic mystery right into our modern reality. Because understanding TFP is exactly how we understand what is fundamentally transforming the global economy right this very second.
Section 2, AI as the productivity engine. Let's bring this into the modern era.
Let's test these variables in our modern context. First up, does AI increase capital? Well, not necessarily. Think about it. When a massive company adopts a powerful new AI software, they might still be using the exact same physical computer hardware, the same laptops, the exact same office servers. The physical capital hasn't grown at all. The physical footprint of that company remains exactly the same.
Okay, so what about the other side of the coin? Does AI increase labor? Again, not directly. Installing an AI agent doesn't magically add physical humans to your talent pool. You still have the exact same number of human employees clocking in every single morning. The physical labor force remains flat, and you aren't paying new salaries to some new cohort of human workers.
And this brilliantly illustrates the solution to our puzzle. If AI isn't showing up as new physical capital, and it definitely isn't showing up as new human labor, where does it go? It shows up directly in our productivity. AI directly increases A, that technology term in our original equation. AI allows the exact same human worker utilizing the exact same physical computer to produce drastically more output. It's like a single programmer suddenly doing the work of an entire development team, or one analyst processing data that used to take a whole department weeks to finish. We're talking about a true general-purpose engine here. It's AI catching critical errors before they even happen. It's making these split-second strategic decisions that a human would totally miss, and automating complex, multi-step workflows so effortlessly that entire global industries are suddenly operating at a completely new baseline of efficiency. It essentially transforms the way we organize our work, allowing companies to scale their output exponentially without scaling their headcount or their physical infrastructure. Economists point out something really profound here. They say, when we observe economic growth that cannot be explained by capital and labor, we may very well be observing the impact of AI. It is the modern invisible force multiplier. It's pushing our global GDP higher, and it's operating entirely within that unexplained, magical margin. So when you hear Solow Residual, don't just view it as some elusive academic mystery or a math error. Rather, it is a definitive, quantitative measurement of human progress. It's literally the mathematical proof of how much better we are becoming at using what we already have. We are maximizing our resources and our potential through pure ingenuity and technological breakthroughs. So here's the bottom line. If you really want to understand the future of global economic growth, don't just look at who is building the most factories or who has the largest population. You have to look at productivity, look at innovation, look at AI. But it leaves us with one massive, lingering question to ponder. If the Solow Residual represents our ability to generate growth without physical limits, what happens to our entire global economy when artificial intelligence pushes that number higher than we ever thought possible?